And welcome to our video on section 4.7 of the Red Book, Transforming Formulas and Literal Equations. All right, so our directions are here at the beginning. We are going to solve the given formula for the variable requested, but in addition, we're going to state any restrictions, if any, for the formula to be meaningful. So what that really means is we're looking for whether we end up with a variable in the denominator. So we want to remember that we cannot divide by 0. So that's what we're going to be looking at for any restrictions. Okay. Oops, meant to highlight that. And so what we're going to do first then is we're going to do a couple of easier questions in the sense that they are going to be one-step solving. So let's go ahead and get started with question number 1, which is volume is equal to base times height, and we are asked to solve for the variable b. So here, what we want to notice is that we have b times h. We want to undo that multiplication, so we're going to divide both sides by h. And that's going to allow us to cancel out the h's, and we're going to be left with our variable that we're solving for, set equal to v over h. Now remember, we said we can't divide by 0, and here we end up with a variable in the denominator. So what we're going to say is h can't equal 0. So we have not only solved for the variable asked, but we've also given the restriction. Okay, so here's another one-step equation where we have b is equal to 2b plus y, and we want to solve for the variable y. Well, notice here that we have plus y, and so what we're going to do is undo, and we're going to subtract 2b. So really what matters here is that it's a positive 2b, I guess. So we're going to subtract 2b from both sides, and that's going to give us a negative b, because these are like terms. 1b minus 2b is negative 1b, is equal to y. Now, that's all we need to do in this one, and because we don't have a variable in the denominator, there are no restrictions. You could certainly leave it this way. I tend to put the variable that I'm solving for on the left, so I would probably write it that way. All right, so we're going to start getting a little bit more complicated. What I'm going to do with this next question, number 3, is next to it, I am going to solve another question, and we're going to just do a quick comparison. So what I'm going to do is I'm going to do a number example. So what if I was solving for 10 plus 8y equals 18? Now again, that's a pretty straightforward solving. We would know that we would want to subtract 10 from both sides. We're trying to isolate our variable. And then we would, of course, divide both sides by 8. And we would be able to find that y is equal to 1. So here when we're solving, we get a number answer, and that's because we only have one variable. But in the example shown, ax plus by equals c, we actually have a, b, c, x, and y. We have 5 variables. So we're going to follow the same steps, but we're going to end up with an expression for our answer. Now, I did make a mistake when I typed this. The variables x and y should be lowercase. So what we're solving for here is, and do pay attention because sometimes those are, in fact, different variables. But in this case, I meant to make the x and y lowercase. So we are solving for y, so we're going to follow the similar steps that we did in the number example. We're going to subtract ax from both sides, and that's going to give us by. But unlike in the number example, we can't combine. So we would probably leave that as c minus ax. Then, again, over here we had to divide by 8. We are dividing here by b in order to get the variable y by itself. Same steps, it's just not as neat when we're done. So here, because we have a b in the denominator, we're going to also state that b cannot equal to 0. All right, so it's perfectly fine, and this is how I would expect most of you to leave this. When we study linear equations later in this semester, we would actually be able to write this as y equals the negative or opposite of a over b times x plus c over b. And that's going to give us an interesting way to look at this equation to go from what's referred to as standard form to slope-intercept form. But again, that's just kind of a preview of what's to come. All right, so now we're going to look at example where we have parentheses, and those can cause us a little bit of difficulty. So what I want you to think about before you start to solve something like this is, does it help to distribute the 2? It's not wrong to distribute the 2. You will get an equivalent answer to what I'm going to get, but what I'm thinking is W is already isolated or by itself in the sense that it has a coefficient of 1. So rather than distributing that 2, I'm going to think, well, that's 2 times the quantity of L plus W. Let me just divide both sides by 2. So that'll give me A over 2 is equal to, and again, we're going to be able to cancel these 2's. So that's going to give me A over 2 is equal to L plus W. And because we're now solving for W, we're just going to subtract both sides by L, which is standing for length. So we would have A over 2 minus L is equal to W. Now if you distributed the 2, you would have gotten a different answer, but it would be equivalent. And so again, you can box that or you can rewrite it so the variable is on the left, but here notice we don't have a variable in the denominator, so I'm not listing any restrictions. Okay, here's another one that has parentheses, and so I'm going to ask you to think the same question. All right, do I really want to distribute the 1/2 h? Is that going to help me solve for the h right there, or is it going to make it messier? Because now I'm going to have a 1/2 hb and a 1/2 hc. So what I'm thinking is I want to leave the h there, but I want to get rid of that 1/2. And it's a 1/2 times h, so we might think divide by 1/2, but remember, dividing by a fraction is tricky. So what we can do instead is multiply by the reciprocal of a 1/2, and the reciprocal of a 1/2 is 2. So I'm going to multiply both sides of this equation by 2. Now think about when you distribute the 2 here, because the distributive property hasn't taken place yet, you do not distribute the 2 into the parentheses, because that would take care of itself if you finished out the problem. So that's why it makes it really easy to clear the fraction, because now what you're left with is 2a is equal to a 1/2 times 2, which is just 1h, times the quantity of b plus c. Again, you might be tempted now to distribute the h, but ask yourself, does that help me get the h by itself? No, we have h times a quantity of b plus c, so let's just go ahead and divide out the b plus c. We can divide by 2 terms, a binomial, it's okay. So what's going to happen is, because I have b plus c over b plus c, they cancel. So I'm left with my h all by itself, and I have 2a over b plus c. So that is my transform formula, but I have to be on the lookout for a variable in the denominator. So I'm going to look at whatever's in the denominator, and I'm going to say, oh, that expression can't equal 0. So again, whatever is there, I'm going to say, ooh, that can't equal 0. Now what I'm going to ask you to do is one more step, and you can choose whichever variable, but I'm going to choose one of the variables and I'm going to solve just for that variable. So I'm going to subtract c and say b can't equal negative c. So my final answer includes my transformed formula with my restriction. I need both. All right, I saved the hardest one for last. So this one is hard for 2 reasons. First, the variable that we're solving for, z, can be found in two places. That's going to require some difficulty, or some difficult manipulation. And the variable is in the denominator. So I'm going to just go over two little side notes. Okay, so if the variable in the denominator is what you're solving for, so I'm just going to say variable in denominator, get it out of denominator. You can't solve for a variable if it's left in the denominator. Okay, so you want to get it out of the denominator. And then the other thing is if you have more than one of the same variable, and that's that you're solving for, more than one of the same variable, group them together. And then we'll talk about how that's going to help us solve. All right, so back to our question. So we have those two issues going on. So what we're going to do is we're going to get that z out of the denominator. How do we do that? So I'm going to rewrite this question just so that you can see it a little bit more clearly. And I'm going to multiply both sides. Z's look a little bit like 2's, so I'm going to put a little line through mine. And I'm going to multiply both sides of this equation by CZ plus D. Let's get that going here. And that's going to allow me to clear the fraction here, because I have CZ plus D over CZ plus D. And on the left, I'm just going to put the W in front. It doesn't really matter with the distributive property, but that's just a little bit easier sometimes to see. And then here we're going to ask ourselves, well, do I want to distribute or not? In this case, you actually do, because you're going to need to group the z that's on the left with the z that's on the right, and there's no way to do that unless you go ahead and distribute the w in so that you have a single term. So now we're going to have, I'm just going to write this in alphabetical order, CWZ plus DW is equal to AZ plus B. So if you remember, my second little pointer was to group the variables together that you're solving for. So I'm going to subtract AZ from both sides. And because I want to get that isolated or by itself, I'm also going to subtract DW from both sides. So I'm kind of doing one step, or two steps rather, in one process. So hopefully you are okay with that. And then we've got the AZ cancels, excuse me, B minus DW. So again, just as a reminder, this cancels and this cancels. So we're left with CWZ minus AZ equals B minus DW. So now all of our Z's are on the left. We need to do what I'm going to refer to as undistribute. Later in the year, we'll call this factoring. But because there's a Z in both terms, it's the opposite of what we did up here when we distributed the W. Here, we're taking out the Z, and we're going to be left with just CW minus A. Hopefully you can see that if I distributed there, I would have gotten what was in the line above. What that does is it allows me now to have the Z all by itself. So I am going to now divide both sides by the quantity of CW minus A. And magically, through the magic of algebra, I have my Z isolated, and it's equal to B minus DW over CW minus A. restriction. Remember, when you have a variable expression like that, I'm going to say CW minus A cannot equal 0. And because A is by itself, I'm just going to add it to the other side and say that CW cannot equal A. So I have my variable solved for, I have my restriction, and that is about as hard as it gets for literal equations. So you're going to now work on the practice problem, very similar to the last problem, but it looks like it didn't print accurately. So I'm just going to fill in here the BC plus D in the video, and then you should have that filled in on your screen. So that concludes this video, other than you completing the question.